Hey guys, today we are going to do kind of a standalone lesson. Um, this comes after our unit on quadratics. So it's after unit 6, but it's going to tie together our 3 different units on linear functions, exponential functions, and then quadratics that we just completed. All right, so these notes, I did post them to your Google Classroom. For those of you who like to print, I don't have an official set of notes to print up. I kind of modified our lesson for today to fit it real quick. Okay, so what we're going to need to be able to do is to compare whether a function is linear, exponential, or quadratic. Well, the easiest thing to look for is a graph. So obviously, linear makes a straight line, all right? And then we have, let's find some different colors. Green, okay, here's blue. Exponential rises or falls very quickly, and then it levels out. It levels out in a single direction, okay? And then a quadratic function makes our U-turn for us. So it's going to face up or down. It's going to face the same direction on both sides of it. And it is going to come down and then curve and go back up. Or conversely, it can go up, up, up and curve and come back down. Okay? All right. So quadratics from graphs or any lines from graphs are easy to identify. So we're not going to cover any examples of those today, but we will look at some examples of how do we identify whether it's linear, exponential, or quadratic from an equation. So linear has an x with no exponent. An x with no exponent, okay? This is linear. So this has no x. This has no exponent, no exponent, no exponent. All right. And this would be x to the 0 power. So you wouldn't see that exponent either. So these are all examples of linear. Let's look at our exponential. In our exponential functions, the x is the exponent. Okay, so 3 to the x power, 5 to the 2x power, that's all right too, and then 4 to the x power. So our x variable is the exponent in exponentials. And finally, quadratics. They have an x squared in the equation, and the highest power is 2. It's important to say that for your future math courses. You will see functions that have a power that is higher than 2 in other math courses. But for Math 1, this will be the biggest exponent that we've seen as far as a standard form of a function goes. So I have an x squared, an x squared, and an x squared. All right, so this is coming from an equation. So let's stop looking in our notes for just a moment and let's come look at some examples that I put together. Okay, again, these examples that I've handwritten out are also posted in Google Classroom. So we're going to look at 3 examples of equations. All right, so examples number 1, 2, and 3. I want you to go through those, just look at them briefly and see if you can identify which equation is which type of function. Okay, so starting with number 1, I do see an exponent, so I know that it's got to be either exponential or quadratic because it has an exponent. So the exponent in this case is a variable. It is an x, okay, which means that this is exponential. In number 2, I also see an exponent. This exponent is a 2, which means that this is quadratic. All right. And then in example number 3, I see no exponent. There's none there. So this will be linear. All right, so those are our 3 examples. And in our practice assignment, you will be practicing this. Okay, let's go back to our notes. Our next step is how do we determine from a table? Okay, so let's zoom back in. So from a table, we can identify if it's linear if you, for one, never see the same y value twice. That's important because we know in quadratics, you do see the same y value more than once because it has the rainbow. All right. And then really the main key thing that we're going to be looking for is the first difference is the same for the y values, okay? And we're going to see what that means. For our exponential functions, the y values change much more quickly than the x values. We will also never see the same y value twice, and they have a common ratio for the y values, okay? Common ratio. Remember, when we say difference, what we're doing is we're doing the y2 minus y1 over x2 minus x1. But really, when I'm finding the difference, I'm only focused on the y values, okay? When I do a common ratio, I am finding the change in the y values divided by the change in the x values. It's not exactly the same slope, but it is going to be, actually, I apologize. I misspoke. This is going to be y2 divided by y1. That's what we're looking for our common ratio. Okay? All right, so that's going to tell me exponential. And then finally for quadratic, the second difference will be the same. Okay? The second difference will be the same. So let's take a look at some examples so that we can help make this make sense here, what I have squared off in these boxes. Okay. So for me, the very first thing that I always try to look for is a first common difference, which if it is a first common difference, it would be linear. So 3 minus 9 would be negative 6. 9 minus 27 is clearly not negative 6. It's negative 18. So first difference is linear, and it's not that. So what we can look for, let's just go ahead and continue this. 27 minus 81, and I'm going to cheat here. 27 minus 81 is negative 60. Okay? Yeah. So the second thing that I like to look for is the second difference. Since I'm already here and I've got the first difference, if it's second, it's quadratic, okay? So let's do negative 6 minus negative 18, and that is going to give me a positive 12. And then if I did negative 18 minus negative 60, that would be, let's see, 40, 60 minus 20 is 40, and then add 2 back is 42. So it is not a second difference either. So I'm going to X both of these out. So at this point, I kind of already know that it's exponential, but I just want to remind you of how to find the common ratio. So the common ratio, remember, is we would take 3 and put it over 9, and then we have to simplify. So this is finding a common ratio. And then I would simplify that and get 1/3. Then I need to do it again. 9 over 27 is also going to give me 1/3. And then 27 divided by 81 is also going to give me 1/3. So this function is exponential. All right, let's go ahead and look at example 2 now. Okay, so let's start by looking for our first difference. So 12 minus 11 is 1. 11 minus 9 is 2. And 9 minus 8 is 1. So in the other side of our notes, let's look here. You did see me put up x2 minus x1 as an option, and we need to do this sometimes.
I don't know that.
Okay, and let me explain why we need that sometimes. If you notice, this is 1, 2, 1, and then look at here. This goes up 3, up 6, up 3. So the x side is also not consistent, and sometimes they'll play tricks on us like that. So if I do 9 minus 12, I get 3. But if I do 9 minus 3, I get 6, and 3 minus 0 is 3. And if I reduce all of these fractions, this simplifies to 1/3. So I do have a common difference, a first difference.
Yeah, I can't see her.
And so this means that this function is linear. Okay, so sometimes we need to divide it by
Is your mic working?
the other side, okay, just to get the accurate change, the rate of change. All right, let's look at example 3. Okay, here we go. Like I said, I always start out by finding the first difference. So 22 minus 15 is 7. 15 minus 10 is 5. 10 minus 7 is 3. 7 minus 6 is 1. This is our first difference. So this is not linear. Not linear, okay? Let's try to find our second difference. So we're going to use this first difference. We're going to do 7 minus 5 is 2. 5 minus 3 is 2. 3 minus 1 is 2. So it has a common second difference, which means that this function is quadratic. Okay, so that's how we can tell by looking at a table. Now, I don't have any notes for what to look for in an application. But let's take a look at some applications anyway, because we've seen applications of these all year long, so we should still have an idea of what we're looking for, okay? So Dan plans to purchase a video game system. He has $500 in his savings account and plans to save $20 per week. So this would look like 500 plus 20 per week. This is a linear function. Let's look at number 2. Allie got $100 for her birthday, okay? And she plans to save up for a car. That says car. She deposits her money into her savings and earns 0.75% interest. So earning is 1 plus. And remember, that percent there is what kind of helps me okay, per month. So that percent tells me exponential. All right, and then let's look at our very last example before you start your your practice problems. A ball is tossed into the air at an initial rate of 500 feet per second from 5 feet above the ground. Okay, so this is going to be quadratic. An initial rate of, this will always tell you that phrase is quadratic. Okay, so it would kind of look like this: 50x plus 5. Okay, and then the initial rate when something is in the air, it's always 16x squared. Okay, so this is a quadratic function. All right, so we've looked at a couple of examples of kind of everything. There are some different application problems for quadratics that look a little different. Also some for exponential that look a little different. For instance, let's say I have a beehive. I start with one bee and she is raising, let's say, 3 baby bees per day. And then the next day she has 6 baby bees. And the next day she has 12. And so that would be growing at an exponential rate. Another example of a quadratic would be I have a pool that is x inches wide and x plus 2 inches for my length, and I want to change the dimensions or do something like that. That would also be quadratic, okay? All right, so I think that you're ready to go ahead and practice now. We did look at examples of each, okay? All right, until next time, guys.